Chemistry is awesome.
Alright, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So welcome back to this channel. Okay, so today's lesson, okay, actually we are still under topic 1.3 and we are still discussing 1.3 stoichiometry, but this time around I'm going to teach you how to balance a redox equation by ion-electron method. Alright guys, so previously in our previous lesson or in the previous video, let's say if you miss out this video, you can find this video in the playlist. Okay, we have already discussed on how to write and balance a simple chemical equation through inspection method. But in today's lesson, what I'm going to teach you is how to write and also how to balance a redox equation. Now this time we have a redox equation and we are going to balance this redox equation by ion-electron method. Okay, so are you ready guys? Good, now let's go. Okay, redox equation. So for this lesson, I'm going to use this reaction, this redox reaction here as the example for today's lesson. So what do we have here? Iron 2, okay, ion reacts with dichromate ion to produce iron 3 ion and chromium 3 ion. Right, so actually this is a redox equation or a redox reaction. Okay, so to balance redox reaction, let's say any redox reaction, actually balancing of this redox reaction could be done in two different mediums. Okay, what are those two different mediums? Actually, we can balance this equation in acidic solution or in basic solution. Okay, maybe you might ask, so when are we going to balance this equation in acidic, or when we are going to balance this equation in basic solution? So no worries guys, because normally in the question or in the exam, okay, you will be given the information, okay, whether the reaction, this redox reaction, occurred in acidic or in basic solution. Okay, so that's why you have to read, you have to read the question properly and thoroughly. Okay, so before we proceed with this redox equation, okay, I would like to highlight this. To balance this redox equation, it requires several steps. Okay, and do you want to know how many steps involved? There are 8 steps. Okay, 8 steps. That is for acidic solution. But when it comes to basic solution, there will be 9 steps. So what are those steps? Okay, I'm going to start with in this lesson I'm going to start with balancing redox equation in acidic medium first, and then later we are going to have a look on how to balance redox equation in basic medium. Okay guys, so let's start with step 1. Okay, step 1. So in step 1, okay, what we are going to do is, remember the given equation just now, the equation with iron 2 and dichromate. Okay, so what we are going to do is we are going to write the unbalanced equation for the reaction, okay, in ionic form. Okay, remember the given equation just now, actually that equation is not balanced yet. Okay, so that's why what in the first step what we need to do is, okay, we need to write the equation. We have to convert the equation into ionic form. But for this case, actually there is no problem at all. Why? Because all of the species, iron 2 dichromate, iron 3 and also chromium 3, so all of these species were already in ionic form. So no need for us, okay, to convert them into ionic form. But let's say you were given a redox equation, and this redox equation, okay, was not in ionic form. Okay, so we need firstly we need to convert the equation into ionic form. So normally ions involved are the one that we are going to leave it in the equation. So let's say if we have a spectator ion in the equation, normally we will omit this spectator ion. Okay, so clear guys? Alright, so now let's move on. Step 2. Okay, in step 2, okay, what we are going to do next is we are going to separate this equation into two half reactions, or sometimes they are also called two half equations. Okay, remember, since redox reaction is a combination of reduction and oxidation reactions in which both of these occurred simultaneously, so that's why when we want to separate this redox equation, we are going to separate separately into the two half reactions. First oxidation, and second is reduction reaction. So what we are going to do, okay, so now let's look at the screen here. So this is the first half equation, the one which iron 2 converted to iron 3, and then dichromate, okay, is converted to chromium 3. Okay, but one thing remains mystery here. Okay, right, so at this moment we still do not know yet, okay, so which ion is oxidized and which ion undergoes reduction. Okay, how to identify that? How to identify which species are reduced and which species oxidized? Okay, it's very easy guys, it's very easy. Okay, so first thing what we need to do is, okay, I'm going to start with iron first, and then we will proceed with chromium or dichromate here. Okay, so for the case of iron, so now let's look at this iron 2 ion. So if we look at iron 2 here, the oxidation number of iron 2 is plus 2. And what happened was, when this iron 2 reacted to form iron 3, the oxidation number changed to plus 3. So what do you see here guys? Yes, what happened to the oxidation number? Yes, the oxidation number, okay, sorry, right, okay, so the oxidation number increases. So in chemistry, whenever a reaction involves the increasing number of oxidation number, increasing values or the charge of oxidation number, okay, we will say that the reaction undergoes oxidation. So now we can say that iron 2 is oxidized to iron 3. Okay, actually once we have determined this reaction is oxidation, so automatically we know that the other half reaction must be reduction. Why? Because this is a redox equation, redox reaction. So in redox reaction, we are going to have oxidation and reduction. This reaction is not called ox-ox reaction or red reaction, so it is called redox reaction. So of course, if one reaction, one half reaction is oxidation, and of course the other one should be reduction. Okay, but okay, we need to prove that. We need to prove that why the second half reaction is reduction. Okay, so it's better we provide with the solid proof why the second half reaction is reduction. So now let's look at the second half reaction. Okay, so this is the second half reaction or the second half equation. So we have dichromate, okay, dichromate ion converted to chromium 3. So to do this, to check whether is this reaction is actually reduction or not, okay, so what we are going to do is the same thing like we did with the previous half equations, okay. Now we are going to look at chromium. Okay, since chromium here in the reactant side, okay, and chromium also, okay, in the product side. Okay, now let's look at what is the oxidation number of chromium in dichromate, and then we are going to have a look at the oxidation of the oxidation number of chromium in chromium 3, because from here later on we are going to determine does the oxidation number increases or decreases. Okay, so for this reaction to become a reduction reaction, the oxidation number of chromium in this reaction must be decreasing. Okay, so now let's check them out, whether it is true or not. Okay, so now firstly let's calculate the oxidation number of chromium in dichromate. Actually, you have learned this before during your SPM. Okay, so now let's look back once again. So how to determine the oxidation number for chromium in dichromate? Okay, if we look at the molecular formula of dichromate, so there are 2 moles of chromium in 1 moles of 2 moles of chromium in 1 mole of dichromate ion. So since there are 2 moles of chromium, so that's why here chromium we need to times 2 or multiply by 2, because there are 2 moles here. Okay, and oxygen, so there are 7 moles of oxygen atom in dichromate, and since the oxidation number of oxygen is -2, so that's why here 7 times or 7 multiplied with -2, okay, equals to -2. Okay, maybe you might ask, what is this -2 actually? Okay, this -2 here actually represent the total charge, and the total charge of dichromate, which is 2-. So that's why here we're going to put -2. Right, so if we solve for this, what we are going to get is the oxidation number of chromium should be +6. Okay, right, so now let's move to the right side here. Okay, for chromium 3, okay, this time is very easy. So since there is only 1 chromium here and the charge is 3+, so therefore the oxidation number of chromium is +3. Right, so now let's look at what happened to the oxidation number of chromium. See, from +6, okay, the oxidation number decreased to +3. Okay, so what is the meaning of this? Yes guys, totally correct. Okay, so means that, okay, from +6 to +3 means this dichromate undergoes reduction reaction to produce chromium 3. Alright, good. Okay, so let's summarize from what we have did in step 2, in this step. So now we know that, okay, for iron 2 undergoes oxidation to produce iron 3, while dichromate undergoes reduction to produce chromium 3. So since both of these reactions occurred simultaneously in the same reaction, so that's why, okay, this reaction, if we combine the 2 half equations here, we are going to get a redox reaction. See, redox, redox rate here came from reduction, and ox here from oxidation. Okay, so these are the 2 half equations. Okay guys, alright, so now let's move on to the third step. Okay, step number 3. Okay, so in step number 3, okay, what we are going to do is we are going to balance the atoms. Okay, but for this step, this third step or this step 3, we are going to balance the atoms other than oxygen and hydrogen in each of the half reaction. Okay, so now let's get back to the 2 half equations. Okay, now let's look at this first half equation. We have iron 2, okay, converted to iron 3. So now what we are going to do, we are going to balance the number of atoms. Remember guys, number of atoms, right? Okay, so here there is only 1 mole of iron. 1 mole of iron. On the right side also, we have 1 mole of iron 3. So therefore, on both sides, iron 1 mole, iron 1 mole. So that means, yes, this equation, this half equations is balanced, in terms of the number of iron atoms. So no need for us to do anything. Just leave it this way. Leave it like this. Okay. Okay guys, clear? Right. Okay, next. For the second half equation, okay, okay, so now let's check. So in dichromate, okay, we have chromium. Okay, we have chromium, right? So in this dichromate, there are 2 moles. See, 2 moles of chromium. Okay, on the right side, there is only 1 mole of chromium. So this means both chromium elements in both sides, okay, actually were not balanced. So to balance this chromium, okay, what should we do? Yes, so this chromium on the right side of this half equation, we will multiply by 2 because we want to balance the number of chromium atom. So remember guys, in this step 3, we are going to balance atoms other than O and H. So at this moment, okay, we just ignore this oxygen. So now we are not going to balance this oxygen. We are going to balance atoms other than oxygen and hydrogen. Okay, so here chromium is 2 and also here chromium is 2, and that makes this half equation in terms of number of atoms other than O and H is balanced. Alright, okay, clear? Okay, now let's move on. Step 4. Okay, in step 4, right, this time we are going to balance the atoms, okay, oxygen and hydrogen atoms. Okay, so what we should do, okay, let's say in the equation or in the half equation contains oxygen. So what we're going to do is we are going to add water, okay, H2O, for example. Okay, for the first half equation, no need to do this step 4 because for the case of the first equation, there is no oxygen, there is no hydrogen in the equation. So no need for us to balance or to proceed with this step 4. So the only half equation that we will focus on is just this equation, the second half equation. Okay, so remember this half equation. Okay, if we look back at this dichromate, there are 7 moles, guys. 7 moles of oxygen atoms here. But on the right side of this equation, there is no oxygen at all. No oxygen, guys. So what we are going to do, we are going to add water on this side, on this right side. Okay, so the question here is, how many moles of water should be added? Okay, so the number of moles of water should be added depends on how many oxygen atoms on the opposite side. For example, so here there are 7 moles of oxygen, and that's why on the right side here we need to add 7 moles of water. Okay, clear? Okay, good. But there is a but here, but when we add water to this half equation, actually we have added more hydrogen atoms. See, if we when we add 7 moles of water, okay, actually what we did was, okay, we add more hydrogen. See, so it's because in water molecule, okay, there are 2 moles of hydrogen atoms. So since we add 7 moles of water, so means that we have added 14 moles of hydrogen atoms on this right side. Okay, so but if we look on the left side of this half equation, there are no hydrogen atoms here. So means that this equation is not balanced in terms of number of hydrogen atoms. Okay, are you guys still with me? Okay, if you need a break, you can pause this video and watch it when you are free, when you feel like you want to continue. But if you're okay, now let's proceed. Okay, right. Okay, so now let's look at how to balance these hydrogen atoms. Okay, so to balance these hydrogen atoms, we are going to add hydrogen ion or H+. Okay, see, since there are 7 moles of hydrogen here, 14 moles, 14 moles of hydrogen atoms, which came from 7 moles of water. Okay, so there are total 14 moles of hydrogen atoms. So that's why on the left side here, guys, we are going to add how many? Yes, 14 moles of hydrogen ions. Okay, so now this equation is balanced in terms of the number of atoms. So if you're not sure about this, okay, we can always check. We can always check for the number of atoms. For example, okay, on the left side here, there are 2 chromium. Okay, right side 2 chromium. Okay, here we have 7 mole of oxygen. So here 7 times 2, also 7 moles of oxygen. So 14 moles of H+. So we have 7 times 2, 14 moles of H. See, guys? Okay, so this half equation is balanced. Okay, so now let's move on to the step 5. Okay, the 5th step. Okay, so in the 5th step or step 5, okay, guys, we are going to balance the charges. This time we are going to balance the charges on both of the half reactions. So how actually we are going to do this? Okay, we are going to add electrons. Okay, we are going to add electrons to only one side of each of the half reactions. Okay, so for example, so remember, okay, this the first half, this was the first half equation, okay, for iron. Okay, if you look at this first half equation, so iron 2, okay, iron 2 ion, the total charge is +2, while iron 3, the total charge is +3. So in terms of atoms, yes, in terms of atoms, this half equation is balanced. But in terms of charges, okay, in terms of the charges, this half equation is not balanced, because on the left side is +2, on the right side is +3. So how are we actually going to balance this different charges? Okay, that's why we are going to add electrons. So how many electrons should be added? Okay, it depends on what are the charges that we are going to look at. For example, so here is +2 and here is +3. So on which side, guys? Where should we add electron? And remember, electron carries -1 charge. So in this case, we are going to add electron on the right side, guys. Yes, right side. Okay, for example, iron 3 plus 1 electron. So since electron carries -1 charge, so +3 plus -1, so the total charge on the right side here is +2, and it is balanced with the left side also +2. So that's why we need to add 1 mole of electron, okay, on the right side of this half equation. Okay, so in terms of atoms, balance. In terms of charge, also balance for this half equation, the first half equation. So now let's move on to the second half equation, the one with the dichromate ion just now. Okay, remember this equation. We have balanced the atoms just now in step 4 for this half equation. So now let's check whether the charges on both sides of this second half equation is balanced or not. Okay, so now let's start with hydrogen. Since hydrogen carries +1 charge, and there were 14 moles of H plus here, so the total charge would be +14. And dichromate, the total charge of dichromate is 2 minus, so that's why you are going to put here -2. And the overall charges for this left side here would be +12. So keep in mind that value, +12. Okay, now let's move on to the right side. On the right side, so here for chromium 3, the charge is +3. Okay, but since there were 2 moles here, so 2 times +3, the total is +6. And how about water? So water has no charge because water is a neutral molecule. It's a molecule neutral. So that's why the total charge is 0. Okay, so therefore on the right side here, the total charge would be +6. However, on the left side, it is +12. See, this equation, okay, this half equation is not balanced in terms of the charges. So remember, in step 5, what we need to do, we need to add electrons on one side of the half equation. So in this case, the electron will be added to the left side. So here, since we want to balance the charges so that the both sides are equal the charge, okay, so that's why we need to add -6 because +12 plus -6, so here would be +6. So in order to get this -6, we need to add 6 moles of electrons. Okay, actually I have one tips that I would like to share with you all. Okay, actually for this step 5, okay, for example, in the first half equation, we add electron on the right side. Okay, right? Okay, so normally when one of the half equation, for example, the electron is added on the right side, normally the second half equation, the electrons will be added to the left side, or vice versa. For example, let's say the first half equation, the electron is added to the left side, and the second half equation, the electron will be added to the right side. So in step 5, actually, for both of the half equations, electrons are normally added on the opposite side. Okay, because why? Because later on in step in the next step, these electrons are going to be cancelled actually. So that's why both half equations, when we are adding these electrons, okay, so both half equations must be electrons must be added on the opposite side to each other. Okay, so clear, guys? All right, so now let's move on to the step 6. Okay. In step 6, we are going to equalize. We are going to equalize the number of electrons in both of the half equations or both of the half reactions. So how we are going to do that? Okay, we are going to multiply, okay, the half equation by appropriate coefficients. Okay, it's like this. Remember, okay, this is what we did in the previous step, step 5. Okay, if you look at the first half equation, there is only 1 mole of electron here, but for the second half equation, there are 6 moles of electron here. See, so the number of electrons on opposite side of these two half equations is different. So 6 mole of electron, so 1 mole of electron. So what we are going to do in step 6, we need to equalize the number of electrons. Okay, maybe you might ask why we need to equalize the number of these electrons, because later on in the next step, okay, we are going to combine these two half equations to form, okay, to form the full redox equation. So that's why in order for us to do that, okay, so the number of electrons on both in both half equations must be equalized. So what we are going to do, okay, with this half equation. So this is 6, this is 1, so therefore the first half equation we will multiply by 6. Okay, and remember, whatever we do to the half equation, for example, we multiply one of the species, others will follow. So means that iron 2 also we need to multiply by 6, iron 3 also we need to multiply by 6. Okay, got it? Alright, good. Next, step 7. Okay, step 7. So in the 7th step, we are going to combine. Okay, we are going to combine, or we are going to add up the two half reactions, and finally we are going to balance the final equation by inspection. And remember, okay, the number of electrons on both sides must be cancelled. Okay, so now let's look back at the two half equations that we have already balanced individually. Okay, see, so this is the first half equation for oxidation reaction, and then this is the second half equation for the reduction reaction. Okay, so since both are separate half equations, so we are going to combine, or we are going to add up these two half equations to produce the final equation, or the full redox equation. Okay, for combining these two half equations, please remember, if the species, if the species are on the same side, they will add up. Okay, they will add up. Okay, and then in other case, let's say we have same species, okay, same species, but on the different side, and in on different side, okay, they will cancel. Okay, they will be cancelled. For example, guys, so now let's look at 6 mole of electrons here. Okay, 6 moles of electron here, but these 6 moles of electron on the right side, and these 6 moles of electrons, okay, were on the left side. So this 6 electron and these 6 electrons, okay, they will be cancelled. Right. Okay, so what we are going to do next, since there are no more same species here, no, okay, so we are going to add up the right side, and also we are going to add up, or we are going to combine, okay, all the species on the left side. And let's look at the full equation, and we are going to get this equation. See, 6 mole of iron 2 plus 14 moles of H plus 1 mole of dichromate. So this is what we are going to get for the left side of this redox equation. And on the right side of this equation, okay, 6 moles of iron 3 ion plus 2 moles of chromium 3 plus ion plus 7 moles of water. So this is, okay, all the species on the right side. Okay, and finally, okay, so this is the balance, this is the balance equation in acidic medium. Okay, however, okay, for safety, for safety, or to make sure, whether what we did in the previous steps were correct or not, whether it is wrong or right. Okay, so to make sure, okay, so that's why we need to verify the number of atoms once again, and also, okay, we need to check whether the charges are balanced or not, just to be sure, or just to be safe. Okay, so let's check together. Okay, so this is the balance equation just now. So let's check. First, let's check the number of atoms. Okay, so there are 14 moles of H plus, or 14 moles of H on the left side, and then on the right side there are 7 times 2, 14. Okay, balance. Oops, sorry. Okay, so they are balanced. And then chromium, there are 2 moles of chromium, Cr times 2, and here also 2 moles of chromium. and then 7 moles of oxygen here. 7 times 7 moles of oxygen balance. Oxygen are balanced. Okay, and then iron 6 mole of iron, 6 mole of iron. So therefore, in terms of the number of atoms, congratulations, okay, they were balanced. Okay, good job guys, good job. Okay, and then let's check the charges. So 14, okay, so here 14, and then the -2 plus -2, okay, 6 times 2 plus, okay, so the total would be 24. So the charges on the left side is plus 24, and how about on the right side here? So 6 times 3, 18, plus 2 times 3 is 6, water is 0, so if total up this, also we are going to get 24. So means that, okay, both sides, okay, the charges are balanced. Good job, okay, congratulations. Okay, we have balanced this equation. Right guys. Okay, so but this is for acidic medium, this is for acidic medium. Okay, maybe you might ask, how about in basic solution, or how about if the reaction is in basic medium? How actually we are going to do that? Okay, so basically I want to be very clear to you, to all of you. Okay, what we are going to do actually, we are going to repeat step 1 until step 8. Okay, but okay, for basic medium we need to add the final step, or we need to add another step, which is step 9. Okay, so here I'm going to use the same reaction, the same equation, but this time let's say this reaction occurred in basic solution or in basic medium. So for this case, okay, so just now we stopped at step 8, but let's say if the solution is basic, we need to add the final step, or step 9, which is this. Okay, so remember guys, when it comes to basic solutions or basic medium, what we need to do, we need to add hydroxide. Okay, we need to add hydroxide. We are going to say hi to hydroxide. Okay, or we are going to add hydroxide to both sides, of the equation. So how many hydroxides must be added? How many hydroxide ion must be added? Depends on how many hydrogen ion appears in the final equation. Okay, so now let's look at the equation. Okay, remember, so let's say we are balancing this equation in acidic medium. Yes, this is the answer. This is the balanced equation in acidic medium. But if the solution is in basic medium, if this is acidic, yes, we are going to stop here. No more step. However, if the reaction is in basic medium, so we are going to add hydroxide. So here there are 14 moles of H+. Okay, 14 moles of H+ or hydrogen ion on the left side of this equation. So to balance this equation, we need to add 14 moles of hydroxide. Okay, and remember, we could not just add 14 moles hydroxide on the left side only, because if we just do this, okay, the equation will not balance. So that's why on the right side of this equation also needs to be added with 14 moles of hydroxide. Okay, so that means this hydroxide ion must be added on both sides of the redox equation. Okay, and the number of hydroxide depends on number of H+ in the redox equation. Okay, and now, so let's look back at this equation. So guys, see here, we have 14 moles of hydroxide, 14 moles of H+. So what happened when 14 moles of hydroxide reacts with 14 moles of H+? We are going to get 14 moles of water. So we can simplify these two Okay, we can convert these two into 14 moles of water. And since on the right side here also there are 7 moles of water, the same water molecule here, so actually we can bring this 7 moles of water to this side, or we can say that we can cancel this water molecule since there are 7 moles of water here, 14 moles of water here, so this 7 will be cancelled, so this 14 also will be cancelled. So what is left in this equation? The equation will look like this. Okay, so will look like this. Okay guys, see, so no more water on the right side, okay, because we have already cancelled the 7 moles of water. So here initially there are 14 moles, so minus 7, so there would be just 7 moles of water here. So once again, to make sure whether what we did was correct, okay, so now once again let's check let's check the atoms, right? So here we have 7 times 2, 7 times 2, 14, so 14 moles of H. So here 14 H, yes, so hydrogen atoms are balanced. Okay, chromium, there are 2 moles of chromium, so here 2 moles of chromium. Okay, iron, 6 mole of iron, here also 6 mole of iron. And now let's look at oxygen. Okay, for oxygen, there are 2 species here that contains oxygen. So in water there are 7 moles of oxygen, in dichromate also 7 moles of oxygen, so 7 plus 7 is 14, and also on the right side we have 14 moles of oxygen. So in terms of atoms, they were balanced. Okay, right, they were balanced. Okay, that is the first thing that we should check. The second thing, once again we are going to check the charges. Here the charges. So here the charge is 0, here is minus 2, okay, and then it's 2 plus times 6, so 12, plus 12, so plus 12 minus 2, we are going to get on the left side here plus 10. Yes, the total should be plus 10. So how about on the right side here? So 6 times 3, which is plus 18. Okay, plus 18, and here is plus 6 because 2 times 3 plus 6. So 18 plus 6 is how many? 24. Good, 24. And here since hydroxide is negatively charged, so we have minus 14. So therefore plus 24 plus minus 14. So on the left, on the right side, the total charges would be plus 10. So on the right side plus 10, on the left side also plus 10. That means the charges are balanced. Alright. Okay, so we have already balanced this equation, guys, in terms of basic solution. Congratulations to all of you once again. Alright, good. Okay, so that's it. So as the conclusion for this lesson, so remember, whenever you want to balance a redox equation, okay, so first thing that you need to do is we must identify, okay, we must identify whether we are going to balance the equation in acidic or basic medium, and then we just follow the steps the steps that I have shown to you in this lesson. And let's say if it is in acidic, there are 8 steps involved, and however when it comes to a basic solution balancing redox equation in basic solution, you need to add step 9. Okay, it has additional step, okay, you might where we need to add hydroxide on both sides of the equation. Okay guys, I think that that's all for this lesson. So I have already covered how to balance redox reaction from using a method that we call Ion-Electron method. So that's all for now. Okay, thank you for watching. I'll be seeing you again in the next lesson. Alright, bye.